Underwater stars got through the Kuiper Belt, causing a lot of erratic trash that's being pulled and pushed through our inner solar system now, and we're seeing this evidence with these large objects that are flybys now. Several 100,000 asteroids have been discovered and given provisional designations so far. Thousands more have been discovered each year. There are undoubtedly hundreds of thousands more that are too small to be seen from Earth. There are 26 known asteroids larger than 200 kilometers in diameter. Our census of the largest one is now fairly complete. We probably know 99% of asteroids larger than 100 kilometers in diameter. Of those in the 10 to 100 kilometers range, we have calculated about half. But we know very few of those smaller ones. There are probably considerably more than 1 million asteroids in the 1 kilometer range near Earth. The total mass of all asteroids is less than that of the Moon. 11 comets and asteroids have been explored by spacecraft so far, as follows: ice flyby of Comet Giobellini-Zinner, multiple flyby missions from Comet Halley-Giotto to Comet Grid-Skeleup and Gilogo flybys of asteroids Gaspra and Ida satellite, near Shoemaker flybys of asteroids Mathilde on the way to orbit and lands on Eros, DS-1 flybys of asteroids Borrelly and Comet Broglie, Stardust flyby of asteroid Anne Frank, and recent sample collection of comets Wild 2 for future we can expect. Habersa Musa C to asteroid Ottawa and Roster to Comet Deep Impact to Comet Tempel 1 and the dawn of orbits Vesta and Sirius. See, they know these asteroids are going to smash into each other in the future dates. Again, these asteroids, there is some debate to the classification of asteroids, comets and moons. There are many planetary satellites that are probably better thought as captured as asteroids: Mars, tiny moons, Deimos and Phobos, Jupiter, outer 8 moons, Saturn's outermost moons, Phoebe, and perhaps some of the new discovered moons of Saturn, Uranus and Neptune are all more similar to asteroids than to large moons. Asteroids are classified into numbers of types according to their spectra and hence of their chemical composition. Type C includes more than 70% of known asteroids. It's extremely dark, similar to Carbonaceous and meteorites, approximately the same chemical composition as the Sun's minus hydrogen, helium and other volatiles. S-type 70%, relatively bright metallic nickel-iron mix with iron magnesium. Type M, most of the rest bright, pure nickel iron. There are more than a dozen or so of other rare types of metals and rock. Because of the basis involved of the observations, the principles above may not be representative to the true distributions of the asteroids. There are actually several classification schemes in us used today. There is a little data about the densities of asteroids, but the sensing of the Doppler effect on the radio waves returning to the Earth from near owing to the very slight gravitational tug between the asteroids and spacecraft. Mathilde mass could be estimated. Surprisingly, its dense turns out to be not much greater than that of water, suggesting that it's not solid object but rather a compact pile of debris. Asteroids are also categorized by their position in the solar system. Main belts located between Mars and Jupiter, roughly 2.4 AU from the Sun, further divide into the sun groups Umbrius, Florus, Pemphiga, Coneris, Eris, Themis, Cybele and Hildas, which are named after the main asteroid in the group. The near-Earth asteroids, NEAS, ones are closely approached the Earth. These are Atlas Major axis less than 10 AU, distances greater than 0.983 AU. Trojans, located near Jupiter, point 60 degrees ahead behind Jupiter in its orbit. Several hundred such asteroids known is in the estimate that there may be thousands more altogether. Curiously, there are many more in the leading large range point than in trailing 1L5. There may also be a few small asteroids in the large amount of Venus and Earth. Between the main parts of the solar system of asteroids in the main belt are relatively empty regions known as the Kirkwood gaps. These are regions where an object orbital period would be a simple fraction of that of Jupiter. An orbit is likely to be accelerated by Jupiter into different orbits. There are also a few asteroids designated in the centers in the outer solar system. 2060 Charon, AK-95 Charon orbits between Saturn and Uranus. The orbit of 5335 Democles ranges from the near Mars to beyond Uranus 5145. Phobos orbits from Saturn to past Neptune. There are probably many more, but such planet crossings orbits are unstable and they are likely to be perpetrated in the future, and NASA is keeping an eye on these ones. The composition of these objects is probably more likely that of comets or the Kuiper belt objects that ordinary asteroids, in particular Charon, is now classified as a comet. 4 Vesta has been studied recently with HST. It is a particularly interesting asteroid in that it seems to have been different situations into layers like the terrestrial planets. This implies some internal heat source in addition to the heat released by long-lived radio waves, which alone would be insignificant in melt such a small object. There is also a giant impact basin so deep that it exposes the mantle beneath the vector's outer crust. Though they are never visible with the unaided eye, many asteroids are visible with binoculars and small telescopes. There are many asteroids out there that are very dangerous. We have one that's following our Earth. It's in a very similar Earth's orbit called Apophis. And we will see this as a flyby between us and the moon. And it's just a situation where we've got to keep our eyes to the skies with this, because every day we're seeing these objects, aren't we? These near-Earth objects. And it's just a case of keeping our eyes up there and using our telescopes, because we are seeing some huge celestial objects up there. And again, these asteroids are coming from one part of the Kuiper belt. Just one part. And scientists are still looking to see what's going on. They know what's going on. They know that these heavenly bodies have got through now. And they've been coming past our Earth for many years. We're seeing more activity now with these asteroids all the time. Other people are sending messages into me as well with objects they've taken pictures of huge asteroids. So it can't be ignored, can it? We can't ignore this, can we? We really can't. Because also the PDCO ensures the early detection of potentially hazard asteroids, objects, PHOS, asteroids and comets. Those orbits are predicted to bring them with a 0.5 astronomical units of Earth, 5 million miles or 8 million kilometers and of a size large enough to reach Earth's surface that is greater than approximately 30 to 50 meters. And also, NASA tracks the characteristics of these objects and issues warnings about potential impacts, providing timely and accurate information. NASA also leads the coordination of US government planning for response of actual impact threats. So they're just keeping an eye on this all the time, aren't they? There is a threat with these huge, massive rocks that are flying past our Earth all the time. And it's just getting really erratic out there from any other year that we've had. We're seeing all sorts of problems. Anyway, take care and respect to you all, and have a safe evening. And thank you for all your kind messages. From Matthew Rogers.